Hello everybody and welcome to another stream of No Orientation Programming. I'm Joe and today we will hopefully, maybe finish our SSH stuff of the server. Last time we reached the point where we were able to send keystrokes with the OpenSSH client and the PuTTY client, but we were not able to send back any frames. So a couple of minutes ago I made a test and it is send where is the hello function? Key received. Yep. Yes. And a test dummy function that is called hello send. And because I wanted to know at which point are we able to send data back to the client. And it turns out that it's possible to send data as soon as the channel has been opened, as this was my expectation. After the channel is opened, we get multiple additional requests, like the request for a session, the request for a PTY or a subsystem, or environment. So I was not sure at which point we can send a data back, but I thought maybe after the channel open, and this was the case. Now I want to see again. Nope. Didn't want to do this. One moment. Yes. So even the control commands are working at this point. That means I am able to clear the terminal screen. Oh, that's cool. As you can see, as soon as I have to confirm the channel open, otherwise it's not officially open. But as soon as the channel is officially open, after the confirm, I can send data hello 1 and after the PTY allocation as well, and after the shell request as well. This is the case for the OpenSSH client. How does the SCP client look like? Let's see. Received message too long. What? Why? Okay, let's see. That's fancy. I hope that I can send. Yes, sending subsystem. Okay, authenticate channel new open. Yes, channel input confirmation. Password. Where is this packet? Send packet 19. 90. We are here, yes. Channel input confirmation send packet. Okay. Send packet 98. What's happening here? Okay. Send packet type 98. Channel input open confirmation. Channel 0. Callback done. Received message too long. I think let's see this number. This number is 48 65 60. I think this is the hello. Hello. Yes, that's the hello. 48 65 60. So this subsystem thing is expecting a different thing. That means I'm not allowed to send a hello at this point. Only if we have a PTY request, then it's allowed. Yes, that's fine. We can still send hello 1 and hello 2. Okay, after the PTY request. The subsystem is a completely different scenario. That means I'm not sure if we can frame to this subsystem channel. Okay, let's see something else. How does the putty client behave? We always have to check how the putty client behaves. Wine putty. Open. Connect once. Foo. Ba. I get hello 1, hello 2. That's fine. Okay. And now I want to see if put is also interpreting the control sequences. Hopefully. Oh yes. Nice, perfect. Everything is fine. Okay. This is very cool. Okay. Now. The hellos are sent only for the PTY at the moment. What is this secure copy stuff expecting. It's sending us a request to a subsystem called SFTP, and that's not the simple file transfer protocol, but it's the SSH file transfer protocol. And for this SSH file transfer protocol, there is no RFC, but only a draft. Don't know. And it's called the SSH file transfer protocol, and yes, this protocol provides secure file transfer and more general file system access. It is designed so that it could be used to implement a secure remote file system service as well as a secure file transfer service. This protocol assumes that it runs over a secure channel, such as a channel in RFC 4251. We have such a channel. That the server has already authenticated the client. We have. And that the identity of the client user is available to the protocol. Okay, yeah. The cool thing here is if we don't give this thing, let's see what happens if we don't give a success message to the subsystem. Subsystem, okay. Okay, now I'm confused. Why? Let's see. Okay, we send a success after we have received the PTY request. Then we send a hello. Then we get another shell request. We send success. And another hello. That's fine. For this client. But what happens? What is happening here? We should send access requested. Okay, opening channel. Fine. Ah, okay. It's similar as before. The Open SSH client does not need a confirmation. This does not matter for us. So okay, fine. One moment. We need another state. and this state is called channel open receive wait. And then, yes, I renamed this state to PTI request, but now it was called channel request before, and I will rechange this because here we can get multiple requests, different types of requests, so I call it channel request receive wait, and before that we have something else. That is receive OK wait, and this receive OK wait is waiting for something else. So what do we want? Yes, that we want to open the channel. And we want that the variable receive OK wait is set. And this thing is set from the outset. Receive OK. False. So here we wait for the client to open the channel. If this is the case, then we set our variable channel is open to true. We do not need a timeout for this. In this case, if not receive OK, break. If it is okay, okay, 1 moment, that's fine. Okay. So we open the channel. Yes, okay. Okay, for 1 moment I will also let's compile this thing. Let's compile. And now we should have the case that we are stuck in the field receive OK wait state. That's fine. But for testing temp, this receive OK is true. We want to establish a channel so we can inform the user that we are authorizing. We are trying to authorize the user. And this receive OK is set from the outside by the user authorizing process. And now we just set it to set this thing to OK. But now we want to check. Yes, exactly. Okay. Do I want to go this rabbit hole deeper? Because we now have a new RFC that tells us how to send files to our server. But this is just a nice to have at the moment. Let's see, general packet format, length, type, request ID. All packets transmitted over the secure connection are of the following format. Yes. Now all packet descriptions in this document omit the length field for brevity. The length field must be included in any case. Okay. The type code for the packet. Each request from the client contains a request ID field. Oh, one moment, please. Okay, whatever. We can make this thing shorter by making a new state. We have a channel request receive wait and then SFTP process state. So this is a special state and special case. And we return proc error log SFTP not implemented by now. And that's it. But in any case, as soon as the channel is opened, we have to wait for the authorization process to allow us to go further. So let's test this last one more time. Connection closed. We got a subsystem request, but SFTP is not implemented by now. Okay. That's fine. We can do this later and no. we will make this different. We don't implement the state like this. We return immediately. And we set another variable that is called is SFTP. But we have another state, I think. Yes. I call this state idle. Yes. So we are going into the state idle. And we say this is an SFTP thing. We return a success message. We say that's an SFTP. Thing. I want this message to be in one stage higher. Channel is open. This is if SFTP is false. Only in this case. And we go to the idle state if that's true. Because the data transfer itself will be done in a different process. The read function should then be able to read. Yes, that's it. Read. Pbuff len, hopefully. No. One moment. We have to check some stuff. Ui. No, that's fine. Oh, come on. Let's keep it that way. And we will do something else. Let's keep it simple. We need the channel is if the channel is open, okay. We have a uint channel ID. Hi Schraufi. Today I wanted to test the new resistor of our DC motor, but I will do this tomorrow. Today I was in coding motivation. How about you? Are you fine? You can answer in German, of course. Yep. Channel ID. If it's open, then we have to set the channel ID, and the channel ID is nice, cool. Are you playing some game? Oh, hi, Loving Scotty. Remote number channel. Oh, a channel number. Do I need a channel ID? Yes, I need, I think. Last time we have achieved a lot of stuff. Very cool at the moment. So let's see if this is compiling. Oh nope. Yes. This is instant question. Yes, of course. Current. Oh no. Number current. Oi. Okay, let's keep it. So what's your question? Yeah, it's compiling. So as you can see, we can, it's very cool. We have what's the most used prefix for members in C and C++? I've seen. I don't know the most used because I have no database, but yes, my strategy is this. I personally use this M thing. If I'm working in a team, then I'm using what the team wants, because I don't want any religion wars. And so if you want to discuss with other team members, then you bring your own religion into the team. But just use the stuff you're happy with in your projects. Just use the stuff you're happy with. Use the thing you like. I'm okay with this M thing. I use P for pointer because it's, for me, these two are important things. Is it a member? If it's a member, I know this is a process state. If not, then it's some global state. outside of the process. If it's a pointer, then I know, okay, I have to be careful that it's accessing the memory in a special way. But the most important thing is that you are happy with your code. You will never be happy in a project team in this area. Yeah, I guess it depends what you're used to. Java people also mostly name the variables without prefixes and use this in the... Yes, there are some people who are using this like this. I'm so annoyed in Python that I'm so annoyed by Python that there is no real this pointer. I always have to type self. In Python, this pointer is called self. And this is so bad because that's one of the cool features of C++. Loving Scotty, do you know the basic languages? I used to write Visual Basic when I was young, when I was a teenager, and for me C++ is nothing else than a fancy if statement. If you have, that's quite cool. If you have, let's see if this is working. Test bus. If you have a structure, a Sinclair computer. Okay, I'm too young for this too. If you have a structure, I don't even know how to write a structure in BASIC, but if you have a structure like my struct foo, and this structure has the members A and B, then you can, in a function, I think it's, yes, we have a sub, and the sub is my subroutine. In Visual Basic, there is a distinction between a subroutine and a function. A subroutine cannot, it's like a void function, no return value. And you can write my struct foo, and then you can write foo.a is equal to 3. And I don't think we need that semicolon stuff. And foo.b is equal to 4. That's one possible thing. And the cool thing in Visual Basic was, or in Basic, I don't know if it's basic stuff or just Visual Basic, you have a with statement. It's not highlighted, strange. And then you can write with foo and end with. And in this with statement, you can write something like that. It's like a temporary this pointer, and that's quite handy, I think. I like this very much. This is actually quite cool. And for me, C++ is just a fancy way for a with statement. And yes, so what I don't like is I'm not a fan of stuff like this, because I want to keep the code clean, and one sign is better than this thing, this big stuff. Okay, but it's depending how you like it. So I don't have any other argument how you should do it, because yes, so we have a lot of stuff is working already. Today we will be able to see a frame, hopefully, and that's so cool. I think there are better places for this. Yeah. comparing objects. Yes. So that's fine. At the moment, we will stop the stuff. I need to open another the parent process. I can show you what is going on there. We have, this is our process 3, and this process 3 tells us that we have connected with foo over the secure channel with the client OpenSSH, this socket. Here we are in the idle filter, because this here we connected with secure copy, and with this client we connected with the OpenSSH terminal client, and because of that we are in the main filtering process and this state, and this main filtering state extracts the keys we are pressing. For example, if I press hello, then we see this hello here. And the cool thing is that the whole communication is of course encrypted. Let's see, we have, how do I connect? I think with the loopback thing. Yes, as you can see, this is a transmission. Nope. Yes, that's an encrypted packet. Here we have an encrypted packet, SSH protocol, and the packet is encrypted. And in our log we see that we have pressed. Yeah, Wireshark is a very, very cool program. That's so cool. And yes, as you can see, it's encrypted, and we also have, and that's the strange thing, in the parent process. So that's what I wanted to show you. This is our main application, the main process of our application, message dispatching. And if somebody connects, then we have a gamer interacting process, and this process communicates with a user, and it's using some other processes to handle the communication. Yes. In some cases, yes. We have implemented the SSH filtering process, and that's very cool. We get keys already, and as you can see, we are in the game selecting process in the state games list. So it's showing us it should show us the list, but we want to do something else, because this is the way for the telnet. This is the games list. As you can see, this time we have connected with an unsecure thing, telnet. We got assigned a name, a random name, because we are not allowed to send any sensitive data. we're not allowed to send any sensitive data through telnet because we can read the stuff I type in. So, and here we get the frame. This is the games list frame, and if I press escape and then enter, the connection gets closed. And the cool thing is this is already working for the SSH client, escape and enter. So we are virtually in the right states, but the frame is not shown to us because this is the thing we implement today. But first we have to implement the user authorizing process, and this is here, this thing. And as you can see, the gamer interacting process checks if the connection is secure or not. If it's not secure, then we start a telnet filtering process and go to the intro screen. If, on the other hand, we have a secure connection, then we start the secure connection stuff. And that's done here. We have an SSH transferring process, and we start this process, and then we start the SSH authenticating process. That this process is responsible for getting credentials over a secure connection. And if we have the credentials of the user, then we tell the user, okay, authentication done, that's fine for us, we accept who you are. But now we want to show this user the result and the progress of the authorization process. And that's the reason why we start two processes. The SSH filtering process is creating the channel, and in parallel, during this phase, we are communicating with a different entity, with another entity, another application that will tell us if a user is known into the system and at which state this user has. So we are starting two processes, and we are waiting for the user authorization process to end. And at first we will not implement this. We make something different. That is, this authorization process has two child processes in it. The first one is showing information to the user. It's communicating with the user. It's like a it's an entity between Vermittlungsstelle, an entity between the user and the server. Yeah, message exchange, whatever. An API, yes. You could call it an API. So, cool. This is a bot. Yes, Shrafi, in Discord later. Oh, yes, I will come later. I see the other guys are in Discord. So this is a board you can see, a bot. That's very cool. So we get a get request over. It's very interesting. We got a get request on port 4000. That's very strange. So Agent Mozilla, someone is connecting with our server. Okay. So to be a little bit quicker, we have to wait until the hard to explain, but it's quite easy. We have two processes, and we want these processes to take place in a concurrent manner, in a parallel manner. That means we have on the one side we have to wait until the channel is open to the user side, because the filtering process needs to establish the channel, but we don't want to wait for the channel. So we don't want to send the request to the authorization server after the channel is established. We want to send the request to the authorization server immediately, and in parallel establish the channel. So we have two states. So this is the first thing we do. We make a state machine with two states. The first state is the visualization state, the user out visualization state. Let's call it this way. UAV. That's fine. We want to display this thing. SSH filter UAV. That's fine. Here as well. So this is the visualization process. And in our main process function, we execute two member functions, and we call them visualize. We want to make everything as efficient as possible and as so we want to do multiple things at the same time. Network communicating over the network is quite slow sometimes. We have to send the requests immediately, as soon as we can, to all the sites we have, to all the peers we have. We want to send all the requests immediately. But if we wait for one party, then we don't want to stall the other ones or stop the other ones. So this is the visualize process, and this process needs to wait. We have a start, and then channel SSH channel ready wait. That's fine. So I need to have a member variable that is called state. I need a transferring process. Nope, I should have a filtering process in it here. Okay. Okay, fine. SSH filtering. We need an SSH filtering here. Lib gaming, yes. Pointer MP field. Authorizing user ID. Authentication ring. So we have the filter, and this filter is null for the moment. And we have a state, and this state is UAV start. UAV state. And here UAV state string. This is for the logging if we want to use the logging. That's fine. Ooh, nope. Yes. So, yeah, that's right. So, and now the interesting part. That's cool. So we have two processes. We have a process state that is stored in the authorizing process during the authorizing process. And we will write this state here. And the visualization function, the visualize function, takes this information of the parent of the authorizing process and gives this information to the user. But on the other hand, it's living. It's not dependent on a state change, because we want something like this. I have prepared the frames. I want to look it like that. We have a frame. The user should see this frame as soon as it's authenticated over SSH. So the client is telling the server, I'm Joe with this password, and this frame should show us immediately as soon as the channel is open. If the channel is open, we can send data to the channel, and we want to send this frame, and we want to animate these dots every second, no matter if we want to send a frame if a second has passed to animate these things, or if the state has changed. The information has changed. If the information has changed, 1 second has passed. So the user is connecting to the server. The server is communicating with some external party, the authorization server, and the user is informed immediately about what is going on. That's very important. The user should always know immediately what is going on. So, okay, let's see if this is compiling. Nope. No return statement in non-void function. Yep. I know. Return pending. Fine. That's cool. So the first thing is done, and this is the visualization state, and we have something else, the user authorization. Control, communicate or whatever. Authorization, the user authorization. Yes, whatever, communicate. So UAV is changed to UAC. That's fine. So we have a second authorize. That's the authorize process. And we just copy this stuff because I'm lazy. Authorize. So this is the part which is communicating with the authorization server. UAC. And we have two states. Visualize the visual state and the authorized state. Whatever. And here we need a C. And then we need this as well. UAV. UAC. State UAV and state UAC. That's UAV start and UAC. And here in this state machine we will simulate a slow connection so we can test all the visualization stuff. Okay. Yes, that's fine. Channel ready wait, temp. And here we have UAC, very important. Oh, yes. Ooh, dangerous. Very dangerous. Ay. UAV, oh. That's very dangerous. So this is visualization. State. State UAC. UAV. UAV, UAC, AC, start UAC, I think everything is fine. UAV, okay, here, and then here. Fine. Start, ready, temp. Ooh. Yes. Okay, UAC. That's fine. Okay, I think this is it. So let's see if we can compile this. Yeah, very cool. Cool. So now we need a function that gives us, so we have to create the authorization, the authorizing process. And we want to connect this authorizing process with the filter. It's communicating over the filter. And for this we need to add an SSH filtering stuff. Pointer p filter. And we give this thing a filter, and then we need this. Or this, I don't know. Let's see. For example, filtering. What are we doing in filtering? We have the same thing with the transferring stuff. I am confused. Where is the default constructor? Did we forget the default constructor? This has to be done at least. Implemented here and defined here, and I think this should be the default constructor, I think. I think this is fine. One default constructor, private. Protected this thing. Let's see. Invalid conversion from transfer filtering to SSH filtering user authorization. Oh, come on, no. Whatever, okay. I have to make a pointer here that is called SSH filtering pointer p filter. MP field, and this MP field thing is MP field is the filter. This is the abstraction. Yeah, I think in the long term I need a more precise pointer. Main interacting. SSH filtering, that's fine. And yeah, let's see, mp filled SSH. Yeah, this is kind of ugly, but I don't care. So I have p filled. This is mp filled SSH. Okay. Because later on, if we are waiting for the authorization to be done, to be finished, and after this we can have two things. Later it will be dependent if we go to the selection start screen, because the user is connecting with a terminal, or we are going to the file upload screen. And for this I need a more concrete pointer to the object. So, okay. Yeah, that's very cool. That means now we need a function that is sending. Let's wait for. Start. Yes. That's the control, the communication thing. Here we need the visualization state is we wait for the ready, and then we say if mp filled dot channel is open. Okay, this is still fine. If not channel is open, then break. If the channel is open, then we go to the temporary state. Proc warning, proc inf, no. Log channel SSH channel is open, and then we go to the temp. Let's see, we should be able to see this message. Let's see, maybe. Do we see this message? Nope. It's too fast. Yeah. Okay. We have to change this to pending. So we don't shut down the authorization process immediately. Now we should be able to see this thing. The user authorizing process is now living a little bit longer. In fact, all the time. We see here the gamer interacting process has a SSH transferring process, a filtering process. It's in the SSH field main state. We have the user authorizing process with two states. The visual state. I was too hungry. The user authorizing process with the two states, visual and authorizing. Visualize. Oh, come on, authorize. It's gambling. It's always a gambling with these tabs. Authorize. Oh, nice. Okay. So, visualize, authorize. Okay. Here in the visualization, we are in the tame state because the channel is open already. So we can send the first hello frame. And we take this frame from the paging process because we have a very similar frame here. Message message out. Yes, that's fine. And we have to adapt this a little bit to, instead of access denied, we have authorizing user. Then we have 1, 2. This is cleared. Then we have these three things. This line. Then we have this line. Oh, come on. Required ring. Yes. And we have this line. And instead it's the second one. It's the third one. So this is cleared. This is cleared. Yes, that's fine. These are the three lines. Then we have empty. Then empty line. Empty. Empty, empty. These three lines have information. This is the progress. Then we have yes, I think this is it. Yes, and this function takes the information from the This function takes the information from the process, from the authorization process, and in home paging, denied. Yes, that's fine. Channel is open. Then we say this message must be a string here in this function. Yes. And then we have and at the bottom we need this. MP field, send the information, the frame information to the user. Okay. Now we have to implement the send function. The send function should use hello send. Let's reuse the hello send function. So we have this thing. We have a string data. Remote channel number. Send. Okay, let's see. No matching function for what? No, this is not possible. Const void. I think. Hopefully, yes, should be fine. Holy moly. Yes, that's it. Cool. So we remove the hello sense. That's cool. This thing is just because we have turned on the verbosity. We have to disable the cursor as well. Can we disable the cursor like... Cool, the Control C is working already. That's cool. Can we disable the... We should be able to disable the pointer. If the channel is open, should be able to disable the pointer. Let's see, this would be cool. if this is working, then this is very cool. Filtering. I say my send function. I think I need this in this very special case. And I have a message. It's all about sending a message. And I want to send a message that is, as soon as I have channel open confirm, the channel is open, then I want to send something. I say message is equal to something. And that is in the telnet filtering process. How can I, yes, that is hiding the cursor. And this one as well. Oh, why not? Yes. I also want to set the terminal title. Oh, that's high. Hopefully this is working. So if I set the message, then it's sending with its own function, and this own function is sending the data through the channel. Oh, dangerous? No, fine, that's fine. Okay. We confirm the open channel. Channel is open. No, not just the channel. We need more. We need it's not just working with the we want to send the cursor only if we have reached the PTY or the shell. Let's say PTY. Okay, let's try this. So I connect. Oh, nice. The cursor is gone. But now it's gone forever. But we have to re-enable this thing. That's fine. At which point do we... key get. If we get the key, we say SSH filter dinit, and in the telnet filter in the dinit we show the cursor. And we have to use this. Okay. So we send the last data through the channel, and then we kill the underlying transfer process. Okay. Cool. Cool. Working like a charm. Everything. Ah, that's cool. So we have our first frame. You're entering TGS. Unfortunately, during the banner, during the authentication, SSH authentication process, we are not allowed, because of security reasons, we're not allowed to send any control characters to the client. We are only allowed to send these boring lines, but at least we could make it a little bit more beautiful or fancy. And that is in the authentication. You are entering stuff. Blob add. We say I have to be careful. Ooh. That's hard. Okay, let's see. I think like this. I'm not sure. Is this compiling? Yes, it's compiling. Yes, fine. I want to have a line above and below that is. Do I need? Yes, I think I need this backslash. Yes. Okay. Fine. Oh, yes. Like this. Let's make it a little bit fancy. Yes, yes, fine. Yep, but yes. Oh, that's cool. It's a little bit more. Should we close this thing? Yeah, why not? Yes. And then I want another new line. A little bit too short. I think. Almost. Yes, I have to make this a little bit longer. I know. I see. Yes, you are entering TGS. Welcome, my friend. And we make this even more beautiful. Now we have a cool banner message. Oh, come on. And if I enter the password, then I get a fancy frame that is telling me, yep, we are trying to authorize you. Please wait a moment and stuff. Okay, that's cool. So we don't need this anymore. And yes, fine. And as you can see, the terminal title is set as well. Nice, nice, nice. We have to change the process architecture of the SSH filtering a little bit, because we are yes, this is the next thing we have to do, and this is not working as like this, because it's a ping pong play. At the moment, the user is able to disconnect with Control and C and should be able to escape. The user may be not authorized in the system, but no matter if it's an authorized user or not, the user should be able to escape. So we have to grant at least the access to input something. Okay. So I can't do this in like here. I have to. I will use the variable. Okay, I will make rephrase this thing. So we jump to the channel request set immediately. We have to remove this stuff. We have to change it a little bit, but that's not bad. So, okay. I want to press escape, and this should be... I should be able to, yes, to get the key. So this visualization thing has a state that is called main, and in this main state I check for a key. But not like here, more like key process. Yes, like not like this, but like game selecting, for example, key. Yes, I need these two things. In authorizing visualization, I have these two things, and I want to get yes, it's fine. Authorization. Oh, I'm getting nowhere here. Hey. Yes. Okay. Trying to hit my hero with my raycast, and it's on the layer I gave Unity, and it's not hitting. Okay. You're coding at the moment, Loving Scotty. Trying to hit my hero. Cool. With a raycast, and it's on the layer I gave Unity, and it's not hitting. There was a streamer who is coding in Unity as well. I don't know Unity at all, but he told me in his stream that there is a strange bug in Unity at the moment. He had a platform, and some collision detection was not. It's very likely not the same thing, but this was kind of a bad bug of Unity. But Unity itself looks quite cool. And then you have made the right decision to open my beer. You know what? I will drink a beer with you. That's a good idea. That's a good idea. Only got a few minutes to because I have a dentist appointment. Okay. Don't overdo it, yeah. Prost. In Hungary they say Eke Sheketre, and in Japan they say Kampai. And cheers. Yeah, Prost. Oh yeah, I feel the energy flowing through my veins. So so what should we do here? We check the filter MP field for keys. It should get us keys, and we should and the authorization. Yes, the user authorization with output username. Yes, a state that is called bool aborted, and we set this thing. Username, yes, here to it's not aborted, but if we receive a key, like this, the abort key, then we say aborted is true. I have bags, kinda not a fan, but I stole it from my dad. I have a Zipferbier from near my hometown. Zipfer Märzen is very cool. Oh, I have. It's no, it's not the pills. It's not the pills. It's a Märzen. Kind of, yeah, normal sweet, kind of. If this thing is aborted, then we have to return positive. The Austrians with beer we never heard of. Yeah. It's a very... No, I think Zipferbier should be available outside of Austria. I've seen it elsewhere. But it's quite local, yeah. So, gamer interacting, looking about now, looks like we got it here. It's a very good beer, I think. It's in my lifetime, I think most of the time I have used this one. So, yes, the gamer interacting stuff, abort, do we have, yes, authorization thing, user authorizing, and we wait for the user authorizing process to end. If it's pending, we break, we still wait. User out done wait. If it's not possible, positive, then we were not able to authorize the gamer. It's kind of positive if. Yes, sure. You can absolutely be honest. Aborted, then return. I'm 35 now and have no idea about your country's culture. Yes, that's... Where are you from? You're from... are you from... I think I know it. Didn't you tell me? It's a mysterious place to me where people speak German but aren't German. Yes, it's kind of... Okay, you're from Germany. What chat paused? No. Yes, it's kind of weird. I have German friends. We are bouldering. Sometimes I haven't been there for a long time, but they are living in Austria now, and it was quite strange for them at the beginning. They were not able to understand us. It's if you are German and you go to Austria, then at first you understand nothing, but after some time it's working. It's very cool. You can see the Germans learning this. It's like German plus plus. No, it's just or it's German minus how you see it, because we are just making it sound not as classy. It's more like slang stuff. Yes, Wien is our capital, yes, and there are quite some differences between the districts, because we have 9 districts, 9 Bundesländer, and I must say these districts are kind of different. Not that big difference, but kind of. But when you look at German culture, we actually wanted to have Austria as part of Germany, didn't we? At least some of the Germans wanted to. Yes, I think. Yes, absolutely. My girlfriend is from Hungary, so it's kind of funny. Her friends told me, how is the small, how did they say, what's going on the small side of the monarchy? I don't know. I think it's called monarchy. I'm so stupid either as well. But you're not stupid, but it's very often we don't know the culture because we just didn't learn it. If you don't know anything about Austria, that's fine. I don't know that much about Germany either. We only know Germany better because all the media we have in Austria is driven by Germany, I think. We have a lot of information from Germany. But I didn't know anything about Hungarian, the Austrian-Hungarian time. The people in Hungary are learning much more about the history. Or at least I was weak in history, so I don't know if we are learning something in history in Austria. This said reset by Pierre. But yeah, it's cool getting to know other cultures. But the culture between Austria and Germany isn't that there is not such a big difference. So there's that one phrase that Hitler, Deutschland über. I don't know that phrase, Deutschland über. It was actually stolen from the time, and all that line meant was, yeah, they stole a lot of stuff. We wanted Austria and Preußen and Germany to be one big country. Yes. Yes. Yeah, you can see it like this. I would rather not finish it, but there's only one word missing. Yeah. No problem. You can see it like this. In the EU, we are kind of united. So we have achieved the bigger stuff. So, we are working together. It's fine, I think. So, yes, that's what I wanted to test. Yes, that's so cool. Everything is working as expected immediately. I love this so much. This software structure, I am so happy with it, because I just code something and it's working immediately. At first I was only able to disconnect by pressing Ctrl and C, or Ctrl and D should be working as well. Ctrl D, yeah. But now I'm also able to escape by Q. D should not work. Yes, D is not working, but Q should be working. Yes. So this stuff is. H is not working, but that's fine because it's not registered as a board key. Let's add this key, or key is equal to H. then we don't have to change the frame. Now we should be able to escape with, not with D, but with H as well. Yeah, nice. Still think this telnet thing is very cool. Yes, I'm quite happy with it. Also, the telnet thing will not vanish. So it will stay. If you connect with telnet, then you are a guest. As you can see, then you have a random gamer name. And I love this. It's cool because you can connect. You don't have to register, and you can play. It's fine. The only thing why I am creating the SSH stuff is because later on, if you create a game like Connect 4, and in the lobby, it was a long journey, but we will improve the lobby a lot. We will make a chat in the lobby and all the stuff. So it will be very cool, but only the ones who are registered will be able to chat. Everybody will be able to make settings and create a server and stuff. That's fine. But and play like normal, but chatting and stuff will be available only for registered people because of all the junk stuff. So I have to this is just a feature, a function I cannot provide to guests. So we have 2 channels. And as soon as this thing, we are very close that the SSH stuff is working. The authorization process will be quite fancy in the end. No, it will not be fancy. The authorization process is quite easy, in fact. The only thing oh, by the way, I have heard about these German devs in the 2000s that created an FPS that was 94K big and looked great for the time. Yes, I have played it. It was brand new when I was 16, 17. And it was crazy. It was so crazy. At the time it looked very good, and so the games at the time, the content it was like equivalent of a normal game was as big as a CD, and a CD was like 700 megabyte, and for the content it was like a 100 or 200 megabyte game. It was quite it was amazing. You were able to play. There were the enemies. You had enemies. You were able to shoot the enemies and all this stuff. It's very hardware heavy, and the graphics were still as big in memory as the graphics itself would have been, but still a great experiment. It generated. I think most of the stuff they were able to the big compression stuff was done because all the graphics were generated by an algorithm. It was quite duplicated. All the textures were duplicated, and all the geometry and stuff was generated. But it was quite funny to play, and a cool project. So that's so cool. By the way, as a tip, by now I always have two things combined. That is the visualization part. If you have some menu, for example, if you have different system components and like audio, networking, whatever, visualization and key inputs, then always try to put. Also, I do this by now because I have realized that for me it's working quite cool. I always combine the visualization part and the key input part because they are dependent on each other. I have seen a strange menu code where I've seen a lot of strange ifs, and this was because the menu part. I mean that in this way, the state of what you show are you showing to the user. For example, you have a menu, then you have a main menu, then you have an options menu and stuff. You go into the states, and in these states define which keys can be pressed. For example, I have a menu here, a main menu for the authorization, and then this state machine is the visualization state machine, and in this state machine I am processing the keys. I'm showing the stuff to the user. I have functions that are for visual stuff like this. This is a visual function, and on the other hand, in the same state machine I have all the key stuff, and that's because you have a control system, a Regelungssystem. If you have a control system, a system block that always has, such blocks always have an input and an output. It's a loop. It's an information loop. You send information into the system with the keys, and in the same system block you have to give the user the result, the answer, the system answer. And if you do it like that, then the code stays very simple, because I'm in this state, in this visualization state, main for example, and then I can get the key and I can process only the keys that are relevant in that very state. Yes, that's a finite, finite state machine, endliche Maschinen, finite state machine, and it's quite useful to code in finite state machines because it's easy to document. You can I don't know if you know, do you know plant UML? Plant UML is one of the very oh, what's that? Come on. You should, if you don't know this, you should definitely take a look at this. You can make a diagram by making a code. So you have this code and you get this. You can make copy to clipboard. You can edit online, yeah. So you can change the stuff, and then you have the result immediately, and that's very cool because you don't have to draw the stuff. That's very, I use it all the time. It's so cool, and because it's fast, it's extremely fast. You can write the text and press enter, and then you have a complete new picture, and you don't have to care that much. You have to care a little bit. You always have to write how it is. Then you get an ugly picture, and then you have to rearrange it a little bit, but if you get used to it, it's quite easy. And then you have a cool picture. For example, I had a problem. I wanted to implement the encryption stuff of SSH, and this was quite hard. It wasn't too hard, but at first I didn't know what I have to do. It was like, this is the transport layer of SSH, and you have to almost like these tools to create manuals for Linux. Yes, they are very handy, and if you have a text written and you don't understand the structure immediately, for me it was quite new, the encryption stuff. Then the encryption is explained. It's explained how the keys are negotiated. Both sides negotiate keys, encryption keys, and this is described in this point, and it's described who sends what. And I just made a picture of this, and this is, for me, it was way easier to implement, because now I was able to see the client is sending me a multi-precision integer along a sequence of long bytes. That is called a multi-precision integer. If you have an integer, this integer could be 4 or 8 bytes, but these have 32 bytes, the long integers, and big numbers. It's called big numbers. And these big numbers are put into some functions, and it's quite complicated at first, but if you have a big picture of it, an abstract view, then you know, okay, I have some function and I have to put this E into that function, whatever this function does. For these functions I have used a cryptography library, so I don't have to care. I just give them the number and I get 2 other numbers, and I make a hash and make a signature. I have a function that creates a key, a host key, and then I just send this to the client, and the client says, yes, that's fine. So it's that's cool, but this made the whole process a lot easier. Yes, we don't have big integer in C. In university, I had to implement a big integer, and it's essentially a list. It's a list. It's a very cool example for an exercise at the university. You have this list in C. It's coding a list in C is quite... Yes, that's numbers that point to other numbers. Yes, absolutely right. That's the reason why I'm not coding in C, because for me C++ is especially that's a very cool idea, so that the computer, the algorithms are manually calculating all the stuff, like multiplication and addition, or the sum, calculating the sum. It's done as you do it manually with your hands. So it's quite a cool idea. Yes, it takes some time, but it's working. And a list in C++ is just a container. It's a data, a complex data type, and it's much easier to use the list in C++, and that's a very, in my opinion, it's a very basic data structure, or a string, for example. In C, you're so low level, it's a little bit too low level. It's annoying. You have just the char arrays. You don't have a list. You don't have a queue. No vector. That's the char array. I use char arrays very often, but they are quite annoying. And so I can definitely recommend this this plant.ml stuff. It's very useful, but in my case it's especially useful because I have made the software structure in a way that it's mapping. It's always a recursive structure, and it always has a state machine. So it's always mapping with the documentation. It's very easy to document. If you are coding object-oriented and you have a big class diagram, then it's a different area. So I'm not coding object-oriented. I'm just coding weird stuff. But I like it. That's the most important thing. So, a lot of stuff is working already. I'm so amazed. I'm so happy with it. It's so cool. So, I'm not implementing the full authorization thing. I just want to, this is step by step. The first step is I have shown this thing, that's fine. I want to test the user interface. I want to test and see what the user sees. And this is working quite fine already. I have to add some more lines, and I will fake in the user authorization process. I will fake the result. The result later will be created by another process. We will start a process here that we will call this process MP communicate, like authorization server requesting create, something like that, and then we will just start the MP communication, whatever, a request, MP request. So we will later ask our internal server if the user is existent, and this is done in parallel. Blog post object for procedural programming. I don't use OP, I just do weird stuff. Yes. Like this, yeah. The only thing is, it needs to make you happy. And I am so happy with the structure. I have created this structure in 2018. I always had this a strange situation. I made a code, and 1 year after that I looked at my own code and thought, fuck, is this code ugly? I always had this feeling. every year that passed, every time I looked at old code, I was like, oh fuck. I was weak at the time. I thought of myself. And this changed since 2018. I'm using this structure in every project and I'm so happy. It's always the same. It's fulfilling the KISS principle. I don't know if you do you know the KISS principle? This it's one of the very few principles. Keep it simple and stupid. This is one of the few principles I really believe, because this is a rule I cannot argue against it. Just keep it simple. But what exactly is simple? For me, simplicity. This is. I think I would say this is true. I can. Yes, for me it's fine. I think it's a cool thing. But the next thought I had was, what exactly is simple? How can a software be simple? And I have found my personal answer to this question, and that is, something in life is simple if it's always the same. And this essentially defined the structure of my software, because I have made it I have made a recursive, a fractal structure, and in every level of my code I always have the same structure. It's always just a state machine. No matter how high or low level I am, it's always just state and waiting for stuff, state and waiting for stuff. If you do it like that, then coding is kind of boring, because you just have to type in what you want. But on the other, so I don't need to think about which concept or which structure do I need, which class diagram do I need, which design pattern. It's just completely stupid, just writing down the stuff. And that's what that is what makes me happy, because if I code something, it's working like a charm all the time. I don't want to waste time on searching memory leaks or memory fuck up or corruption or strange state stuff. Here it's very simple, and the server is doing quite a lot of stuff already. Multiple people can connect. Oh, I can extend it to readable. Yeah, it's I can split the terminal. No, not like this, but like this, and then I can make another telnet localhost 4000. 4000. And then I can join, and all the stuff is just so easy. It's easy implemented, but it's doing quite a lot of stuff, I think. So I'm quite happy with it. So yes, I want to see, this is one of the reasons why I make this project, because I want to see how long can I write in this structure. how long I always had the one problem when I made a project. At first it was fine, but then when the project was older, bigger and older, then it was, I had a lot of bugs all the time. I always had a lot of bugs because the system got so complex, and I want to see if this has changed with this structure. If it has, then fine. If not, then I have not found an answer to a question that I have for a long time. So essentially this streaming stuff is an experiment. Yeah, I'm quite curious what the outcome will be. If it's not working, then I will try to switch my job being a baker. What is baker called? I'm so bad at common English words. I only know the baker. Oh, come on. Baker, yes, baker. I only know the technical words. So bad. I would make a Umschulung. Was heißt Umschulung? Umschulung. Retraining. I would make a retraining to a baker. So, but the SSH stuff, all the encryption stuff, all the fancy stuff, I needed only a very few days for it, and that is kind of a good performance, I think. But it was just easy now, because if you do it like that, then you just have to execute functions after function, and with this structure you are able to make things parallel, like here in the authorization process. I just execute two functions, and they are essentially parallel. They are not parallel in real, they are pseudo. Really? You were an intern in for a baker? Cool. Yeah, I think at the moment it's quite hard because of the energy costs. Many bakers are complaining, and it's really hard for them at the moment. But the job, I think, the job itself is cool, I think. So, okay, what do we need? We need, yes, something like that. Interacting user, no, not interacting, game selecting. Game selecting process. I think there must be some start. Yeah, whatever. So let's make the animation. The next thing we will do is the animation. That's mstart UAV. If we wait, at first we wait for the channel to be ready. Then we wait for a key on the one hand. Yes, fine. And for this we make... Yes, was nice to see you. Good night and gute Besserung for your doctor thing. Oh, the fucking Twitch chat. Was nice to see you, and hopefully we see us again. And good luck with the doctor. Have a good night then. Bye. Keys process, okay. Mm-hmm. Mm-hmm, mm-hmm, mm-hmm. 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 Start. Boah. Oh, come on, what the hell? Yes, dot cont. Let's see. And 30. UAV, start UAV 30. And that's the dot count. That is 0. Yeah, come on, nice. And that count is 0, fine. Now. Start. Okay. So that's the start of this thing. If diff ms yes is bigger than 1000, then we say dot count plus plus dot count if dot count is bigger or equal than 4. Then it is 0 and M30 is true. That's fine. And in this function, the progress, yes, poohoo. Come on. Yes, fine. So that means we have to cut here, remove 3, cut here again. Yes. And then we have to for int. Yes, let's see. Not declared. Oh, yes. Start. Unused variable. Yes, that's true. And break statement of switch. Yep. Mm. Mhm, mhm. Define dot count max is equal to 3. And that is minus dot count hard to say. Let's see. Okay, this thing should be working, but I think I have missed very likely this thing. Let's see. I think I have the wrong... I have the wrong destructor used. Yes. Actually, I don't like this. 11, no. 2 and 50. The half is 84, so that means no, what 48. The half is 24. So this is the middle actually. Okay. That means I will change this. And I want to start with 1 and plus 1. No. If it's bigger than max, then start. Come on. Start 1. No, not start. Oh, come on. Oh, I think this is the beer. Whatever. So. If it's bigger than count max, then we go back to count start. And I have to remove one of these. Oh yeah. I don't want to show this thing. That's so cool. We are almost done with the visualization part. Okay. I make three variables that are called integer 16 type credentials. Okay. Verified and active. Yes. And then I set to 0. And then if not else if else. Yes. The hell? What did I do? Frames. Access denied. Come on. Ah, damn it. Just one. I think I have. What is going on? I think I didn't. Yes. Okay, that's fine. Yes, this is the prototype. This is the prototype. Okay. As long as there is no information, we print this. Otherwise, we print we could make it simpler. I cut 1, 2, 3 from here. And I cut 1, 2, 3 from here. And then I have, that's way easier. Yes. Here we have this. Okay means okay, and this means no. Yeah, fine for me. And we want to have this colored. Oh, come on, coloring. I have color in games, Connect 4. Image. No, this must be in lib matching. Color theme 1. Bright green. Foreground 92. The user authorization visualization color okay, and red is color not okay. I think this. Define DUAV color stop. Ah, come on. Not okay. In all cases I can make this. So, yes. Okay, credentials. It looks weird. I don't know why, but it looks like this is not in the center. 3. Then let's make 5. Dot max 5. And we erase 1 here. But that's fine for me. Okay, so I want to check if how does it look like if if the credentials are okay, then I have a big okay, but it's too shiny. That's too shiny. Because it's bold. Hey. Ah, no. Foreground. I have to use the non-shiny version. And that is... what? 3, 3? But I think this must be 0. I can remove this thing, I think. Yes, that's fine. Just a normal screen, okay. Then I want to make credentials -1. And that's no. Credentials, no. Oh yeah, that's looking better. That's looking better. So I have to retest this. 0. Fine. +1. Okay. Fine for me. Then the same thing with... I think I can just... Oh, boy, that's so bad. Right. And then std const std string reference title and caption and integer 16 state task state. What the hell did I do? Oh no, that's fine. Credentials. Yep. A message task line. Message. Credentials. Credential. Okay. Account verified. Account active. Yes, that's fine. And now I have to cut again message plus equal to some stuff. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Ooh. Define DUAV task that len max is equal to 19. Oh, come on. Then we have to split this again here. Okay. And then we say title. Yes. And then we say string. Skip dot skip is false. True. So I have to make this. If if dot skip crazy. Okay. I think this is it for today. That's quite okay. So we have the visualization process implemented. We have a cool frame. It's even animated, and I think this is it. Yeah. So game selecting, authorizing. Yes. How much did we change? Quite a bit. Documentation. Nope. Resources history. Come on. Implement. Add. Authorizing frame. Yes. Improve SSH filtering. Banner. Yes, that's fine. Yeah, that's cool. SSH transferring. Add. Add frame. Yes, fine. Cool. Yeah, that's fine. That's cool. Okay, so I have to go to the toilet. But first we have to raid. I want to raid somebody. Ooh, Gyros. Gyros is cool. Be right back, Döner. He is coding VHDL stuff. That's very cool. I have to raid, and I will raid silently. Raid. It's not boring. So let's see you on the other side. See you next time on Tuesday. Have a good night.